Hello, welcome back to Bento Sushi Live Noding. In this episode, we're gonna discuss a concept using animation nodes. I call it animation chaining. I don't know, it probably has a different terminology, but basically, we're gonna end up with an animation that looks something like this. Basically, I'm rotating Susan head. I think it's 30 degree for every step, and this is just like similar animations that you might see if you are rotating the arrow of the clock, and this animation is gonna go on forever and you don't need to animate every second, but you can see there's a kind of nice interpolations happening. And then yeah, I think this setup is very cool, but here the node tree looks something like this. Looks pretty complicated, so but I will explain it a little bit easier if I actually start with something like this. So first of all, we know that we're gonna animate head for from one point into another point. Like we start from just using a single node first, just animate Euler. And this should be pretty easy to understand. Don't worry about these guys right here. So we have this time goes into animate Euler, and this animate Euler is for you to rotate between this start angle to the end angle. Should be pretty easy. So it just rotate Susan head from this 0y to 30 degree in y. And this is the durations, and there's these interpolations. So this is pretty simple, just like a normal keyframing animations. So you have 20 frames to rotate Susan head, and that's actually just a single, you can call it like a single action animation. Let's say you want to rotate it, so from 0 to frame 20, Susan head rotates 30 degree, and there's this interpolations. So there's a nice ease in, ease out. If you want to continue rotating, apparently you can easily do that simply by chaining this animate Euler. So look at here, the output of time goes into this guy right here, the same node, and the result goes into the start. So the end keyframe or the end value goes into it becomes the start value for the next action. So by doing it this way, you're gonna have Susan head rotate to 30 degree, and then the next one rotate to 60 degree. So two actions happening. And if you want to do it again and again, you can chain the same actions over and over again. And we have 4 nodes doing this chaining of animations. So 1, 2, 3, 4. So that's pretty cool, and we can actually do this forever just by chaining a single time that goes in and out through this node. I think this is a very important concept with animation nodes. I didn't think too much about this until the other day. I was thinking, hey, I want to animate it just like a clock and rotate it for every single like a click. Okay, so we can do this forever and ever, but it's gonna be like pretty boring to have to create nodes. Maybe you can use Python scripting to do that, but this is probably not the most efficient way to do it. So this is another setup that's probably a little bit better. With this setup, we just need to provide like a list of numbers for the angle. So here, what I have here is I have 300, but I can just reduce it to 12 for now. 12 times 30 is 360. So we're gonna end up with a Susan head rotating 360 degree until it goes back to the original positions, and then we can kind of loop it if this is the clock. So yeah, I have this setup, looks something like this. So basically, like I said, we have I first generate 12 value for the angle, and what's happening here is I basically get the first index and then the first index plus 1 for the least. So we're gonna end up with this value. The first value is gonna be 0, between 0 and 30, and then with this setup, when it goes like a certain durations, as the time passes, you see this guy right here gonna suddenly becomes 30 and 60, and then continue on, it's gonna become 60 to 90. So it's like a kind of like a click. The click, or in programming term, I think they call it like a tick, or like a beat in musical term. So this is very important for procedural animations. It's like for every tick, the value should move from start to the end, and then continue on and on until it finishes. So this is like kind of like a repetitive value. This kind of thing would be hard to do if you are animating it manually. Well, you can of course use all kind of tricks to do this kind of repetitive animations, but I'm pretty sure after a while, if you want to do this and then you make changes, it's gonna be a lot easier to do it this way, using a procedural way to do it. I'll give a quick breakdown of what's exactly happening. So let's see, this is durations. I'll make the durations becoming 5. That's gonna be the how long it's gonna move from the starting angle to this end angle. So we are still using this animate Euler node, but we only be using it once. Up here with the chaining, we need to use it for every rotating actions. But down here we only need to use it once, and all we need to do is really just set it up so that the start and the end need to change for every click of action. So that's exactly how it works. I have this just a single time info node, and this one actually goes inside a loop. So this frame will be looping forever and ever between two values. Like okay, let me explain it. So the times will be like from 0 to 20 in this case, and it's gonna be looping forever. So 0 to 20, looping forever and ever, and this node's gonna process that time information. So we are done with time, but the start and the end gonna change for every click or every bit. And this start and end, really the value comes from this generated list that goes into this get list element, and we are actually picking the index value that's so this one is this one picks the index 0, the other one will get the index 0 plus 1. That's why I have this math plus 1. So by this setup, we really have this procedural kind of animations that simply rotates Susan head for every tick. It's gonna kind of push the head to continue animating until it goes 12 times, and then suddenly it stops and back to 0, 0, 0. And for the animation itself, I give durations of 5, so it's gonna do the animation for 5 frames. While since we have like a 20 for every tick, that means minus the actual animations, we're gonna have 15 frame of hold. So in animations, hold is also very important. So in this case, what really happening is that, let's say we rotate Susan's head from 0 to 30 degrees. So that's gonna be the first action. This is gonna take around 5 frames. And then we're gonna hold it, have a rest for 15 frames, and then continue to the next animations from 30 to 60 for another 5 frames, and then hold it again for 15 frames. So it's gonna repeat the same step over and over again. So this is the concept that I want to teach you, give you a demo in this case. I'm not sure if this can be simplified. I'm pretty sure it's possible. Maybe I need to consult JAX or other animation nodes developers. But here you go. This is one example how you can do it using animation nodes. So it's very, it needs kind of like a procedural kind of thinking in order to understand this. But once you get it, okay, you can actually kind of create a kind of like a complex setup using this concept. So imagine if you are like, instead of rotating Susan's head, you need to animate an object from position A, and then you move it to position B, and then this is becoming a single action, and then you want to continue for the next one. You want to animate from position B to position C in a random fashion. You can do this pretty easily. This is gonna be like kind of like automated animation. So instead of chaining it, and this is like the manual way to do it, even though it's still like using nodes. But I think if we are like when we get one day we get like the action nodes, we can start to think about chaining action procedurally this way. So it's almost like it's actually almost like a Blender and NLA, nonlinear animations. Where is it? This way, NLA editor. So but we're probably gonna discuss that in the future video. But yeah, for now, this is what I'll give you these blend files to have a look. And yeah, that's pretty much it. Thanks again for tuning in. Hopefully this is useful for you. Let me know what you think. If you have any question, feedbacks, let me know, and I'll see you next time. Thank you. Bye.